In this video, we will solve problems from exercise 1.2, but before we go into solving the problems, let's just have a quick look at some of the important definitions and things that we need to know. Now, first thing is that constants and variables. So, what is a constant? A quantity that remains unaltered throughout a mathematical process is called a constant. That means a constant is a number that does not change. It remains the same throughout the mathematical process. Then a quantity that varies in a mathematical process is called a variable. That which varies is called a variable. A variable is an independent variable when it takes an arbitrary independent value not depending on any other variables. So independent variable is not dependent on any variable, whereas if its value depends on other variables, then it's called a dependent variable. Let me show you some examples here. Now, area of a rectangle is A is equal to L into B. Now, this L is the length and B is the breadth. A rectangle can have any length and any breadth. So, depending on its length and breadth, we'll be able to calculate the area. Now, area is completely dependent on the length and the breadth. So this A, the variable A, is called a dependent variable. But whereas the length and breadth can vary, they are not dependent on the area. Area is dependent on the length and breadth. So the length and breadth are called independent variables. So you have length, breadth as independent variables, and area is a dependent variable. Next, if you take a look at the area of a circle, it's A is equal to pi r squared. R is the radius. Again, the radius r is an independent variable, whereas A, the area, is a dependent variable which depends on the variable r. Now let's look at pi. Pi is a very constant value, doesn't change at all. So this pi is called a constant. So similarly for the cuboid, you have B as a dependent variable, length, breadth, and height as the independent variables. Hope this gives you a short introduction to what is a constant and what's a variable. Next, let's look at what is an interval. A subset I of real number is said to be an interval if I contains at least two elements. That means A and B will be two elements of I, and there should be a C which lies between A and B, and C belongs to the interval I. So this such condition is called an interval. Now there is finite interval and infinite interval. Let me explain what's an infinite interval first. Infinite interval is an interval such that there is no definite number where it ends. It goes to infinity. So it can be infinite to the right or infinite to the left. So all these are called infinite intervals, whereas these are finite intervals. Now you have two more concepts here. One is called the open interval, second is called the closed interval. Now for the open interval, you use these curved brackets, and for the closed interval you use the rectangular brackets. So what would this mean? If you say an open interval, we can see this example here. An open interval, A is less than X and it's less than B, which means X is never equal to A or nor equal to B, but it's going towards A and it's going towards B. So you cannot define what's the end term. It can be 0.999999999. It never touches A. It's just that just little away from A. So we can't give a specific value for it. So that's why it's called a open interval. Whereas in the second case, you see here, X is between A and B, and it can be A, it can be B. That means in the interval, it ends with the A, or it begins with the A and it ends with a B. So this is called a closed interval. So similarly, you have in the third case, the interval which is open to the left. It's open to the left because A is less than X. And here in this case, it's open to the right because it is X is less than B and not equal to B. So similarly, you have these intervals. Now, whenever it's infinite, you will put a open bracket. It's an open interval. So all infinite intervals are open intervals. So here you see this example where X is less than or equal to B. So it's equal to B. Therefore, you have the closed bracket. Whereas in the left it is infinity. So you have the open bracket. Next, let's understand what's a neighborhood. So by definition, neighborhood of a point A is any open interval containing A. So if there's an open interval, let's call this as the interval, where it is in the left, it's a left open interval A minus phi, and this is A plus phi, and this interval contains A. Therefore, this is called is the neighborhood of A. So neighborhood of a point A is any open interval containing A. In particular, if phi is a positive number, usually very small, then the phi neighborhood of A is an open interval. So that will be the interval A minus phi, comma, A plus phi. The set A minus phi, comma, A plus phi minus A, which means if this interval does not contain A, but A is in between, it falls in between, but it does not contain A, or it's deleted, A is deleted from this interval, then this is called a deleted neighborhood of A, and is denoted by this 0 is less than X minus A and is less than phi. Next, let's look at a very interesting topic, which is relation. Let A and B be any two non-empty sets. A relation R from A to B is defined as a subset of Cartesian products of A and B. Symbolically, R is a relation, or the set of all relations is a subset of A Cartesian product with B. So what this means is you have, let's say this is A and this is B, and there is a relation for the elements which are in A to B. So like here you can say A is related to 1. So this will be A comma 1, B comma 2, C comma 3, so and so on. Now the relation starts from this set. Let's call this as A. So this set from where the relation starts is called the domain, and where it's related to is called the range. And here are some examples of how you can show relations using the graph. Now consider y is equal to 2x. Now x is the domain and y is the range. For each value of x, there is a corresponding value of y. So this is called the relation. Similarly, you have, y is equal to x squared will have, for each value of x, you will have, a value of y. Similarly, for y is equal to root x and y is equal to minus root x, you can establish relations between x and y. Now consider a set S. Let's just take this as elements which has A, B, and C. Now there are three types of relations. So first, reflexive. So as a relationship is said to be reflexive if A is related to A, right? Then, so this is reflexive. If A is related to B and B is related to A, then this is called a symmetric relationship. If A is related to B and B is related to C, which implies that A is related to C, then this relationship is called a transitive relationship. We will see more of this as we do the problems. So these three relationships are called the basic relationships. Now, let S be any set. A relation of S is said to be, on S is said to be an equivalence relation if it is reflexive, symmetric, and transitive, which means if they satisfy all the three conditions, that is reflexive, symmetric, and transitive, then the relation is called equivalence relation. Now, we can also define inverse relation. So let's say if R is a relation from A to B, then the relation R inverse defined from B to A by R inverse is equal to the Cartesian product B comma A, such that AB belongs to the relation R. This is called the inverse of the relation R. Now let's get into the exercise. Question number 1. Discuss the following relations for reflexivity, symmetricity, and transitivity. Question number 1. The relation R defined on the set of all positive integers by M related to N if M divides N. Alright, so let's do the first one. So you're given a set, let's call it a set S, which is equal to set of all positive integers. Right. So let's look at the first relation, which is reflexive. So if M divides M is related to M, which is M divides M is possible. Therefore, it is reflexive. Now the second relation, which is symmetric. Okay, so let me underline these. Now let's consider that it's actually given to us that M is related to N if M divides N. Therefore, if M divides N, then N does not divide M. Just for example, let's say that 6 divides 12. This would mean 12 divided by 6. This is possible. But can we say 12 divides 6, which is, this is not possible. Therefore, we can say does not divide M. N does not divide M. Therefore, it is not symmetric. And the last relationship, which is transitive. So M is related to N, and let's assume N is related to R. Then this should imply that M is related to R. So let me just show you an example here. Let's keep the same. 6 divides 12. 12 divides 24. This will imply that 6 divides 24. Therefore, it is transitive. Question number 2. Now, let P denote the set of all straight lines in a plane. So let's say P is equal to set of all straight lines in a plane. The relation R defined by L related to M if L is perpendicular to M. So let's say that this is our L, then this is our M. So they are perpendicular. Okay, so that's the relationship. So let's look at the first relationship, which is reflexive. Is L related to L is not possible because L is not, since L is not perpendicular to L. So it is not reflexive. Yeah, so I hope this is clear. L is not perpendicular to L, but you can say L is parallel to L. So this relationship is not reflexive. Now the second one is symmetric. So for symmetric, you need L related to M and M related to L, which means L is perpendicular to M and M is perpendicular to L. This is possible. Therefore, it is symmetric. Then let's look at the third criteria, which is transitive. Here, L is related to M, which is, instead of writing this, let me write the relation. L is perpendicular to M and M is perpendicular to N. So let me say there's another line here, N, and this M is perpendicular to this N. Now from the picture you can see clearly L is not perpendicular to N, which implies L is not perpendicular to N because L is parallel to N. Therefore, it is not transitive. Now for question number 3. Let A be a set consisting of all members of a family. So you have the set A, which is equal to all members of a family. The relation R is defined by A related to B if A is not a sister of B. So the relationship is defined as not a sister. Right. Now let's look at the first case, which is reflexive. Let's consider that A or A, this will imply A is not a sister of A. This is true. Therefore, it is reflexive. Now for symmetric. Before I explain symmetric, let's look at an example. Let's say Kala is a sister and Ram is a brother. Okay, Ram is brother of Kala, Kala is sister of Ram. So you can say Ram is not a sister of Kala. Whereas you cannot say Kala is not a sister. This is of Ram because this is false. This is false because Kala is a sister of Ram. Therefore, A or B need not imply B or A. So we can say that A related to B implies A is not a sister of B, and this need not apply B or A, which is B is not a sister of A. Therefore, it is not symmetric. The last is transitive. Again, A or B would mean A is not a sister of B, and let's say B or C would imply B is not a sister of C. Now this need not imply A or C. Therefore, it is not transitive. Now for the fourth problem. Let A be a set containing all female members of the family. So set A is equal to all female members of a family. Okay, now let's look at the first one. Let's say that the relationship is A is not a sister of B. So it's not a sister, it's a relationship. So let's say A or A would imply A is not a sister of A, which is true. Therefore, it is reflexive. Now B, A is, let's say, related to B, which this would imply A is not a sister of B. B or A. B is not a sister of A. This is possible because it's within the family, all the female members. So if A is not a sister of B, then B is not a sister of A. Therefore, it is symmetric. And let's say A is not a sister of B, and B or C, which is B is not a sister of C. But this might not imply that A is, this would actually we can say that this is not possible because A can be a sister of C. Therefore, it is not transitive. Question number 5. On the set of natural numbers, the relation R is defined by x related to y if x plus 2y is equal to 1. Alright, so let's say our n is equal to set of all natural numbers. Right. Next, let's look at the first criteria. X or x. Is this possible? Is our question. So if x plus 2x is equal to 3x, and this is supposed to be equal to 1. This would imply x is equal to 1 by 3 and is not a natural number. Therefore, it is not reflexive. Then let's go to B. X is related to y and y is related to x, which means our x plus 2y plus 1 is equal to 1 does not imply that y plus 2x is equal to 1. Therefore, it is not symmetric relation. Then the last, x related to y, would mean that x plus 2y is equal to 1, and y related to z would mean y plus 2z is equal to 1. So let's try and solve this. So our y is now equal to 1 minus 2z. Let's substitute that onto the first equation. So let me call this as 1 and 2. So applying it on 1, this relationship, you get x plus 2 into 1 minus 2z is equal to 1. Further simplifying this, x plus 2 minus 4z is equal to 1. This would imply x minus 4z is equal to minus 1. So this does not imply x is related to z. Therefore, it is not transitive. Need to add the not here.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.